A common situation we're going to see is we want to multiply like maybe a binomial times a binomial. So to kind of introduce this, I want us to remember maybe how some of us learned to multiply, for example, a 17 times a 13. Now some of us learn to do this not through the algorithm, but through a visual type of a way. 17 is the same thing as a 10 plus a 7. 13 is the same thing as a 10 plus a 3. Well, what that means is that we're multiplying. We're actually looking for the area of something. So we might take a rectangle. We would make this side 17 and this side by 13. 17 times 13 produces the area in the inside. However, if I broke it up as a 10 and a 3, watch this, or a 10 and a 7, in this 13, I broke it up as a 10 and a 3. I created 4 different shapes. Finding the area of each individual shape, this is a 10 by 10. 10 times 10 is 100. This shape over here is a 10 by 7, which is 70. This shape down here, 10 times 3, makes it a 30. And this last little corner here, 3 times a 7, it's a 7 by 3, which produces a 21. So if I took all the individual areas and added them all together, 100 plus 70 plus 30 plus 21 produces 221. 17 times 13 equals 221. To prove that, let's look at the algorithm. 7 times 3 is a 1, carry the 2, 3 times 1, 1 plus a 2 is a 5. Gives me a 17, add those together, I get 221. But it's important that we have this idea of what's happening. Multiplication means we're kind of looking for the area that's created by 2 different numbers. And so sometimes visualizing it into smaller chunks and then adding those chunks are helpful. Reason why? Let's imagine that we have an x plus a 3, x plus a 3 times an x plus a 2. Well, in that same type of an idea, if you recognize this as some type of an area where I have an x and a 3, and I have an x and a 2. This creates different shapes. So I have this square right here is my x times my x, which produces a x squared. What's the area of this rectangle? Well, it has height x, length 3. That becomes a 3x. This one right here has a height of 2 and a width of x, which becomes a 2x. And this last little square, its dimensions are 2 by 3, which produces a 6. And then from there, I collect all my terms. Produces an x squared, 3x and a 2x gives me a 5x, and then I have a 6 at the end. These are unlike terms, so I cannot add them anymore. So visually, when we're asked to multiply something like a binomial times a binomial, we're kind of asking, well, what are all the smaller chunks added together? Another way to look at this is a process that we'll probably use most often is recognize that we have a double distribution coming on up. Now, what do I mean by that? Well, let's write this out. X plus 3 times x plus a 2. And if I remember, if it was just the 3, we would distribute that 3 to both of those terms. However, since I have a binomial this time, not just a monomial, but there's 2 terms, I need to also multiply this first term by everything as well. So notice I have 4 different operations that I'm building here. So let's look at that. Let's start with this x times this x, this first line right there. That's an x times an x, which produces an x squared. The second line, x times the 2, makes a 2x. Okay, we're done with multiplying the x times everything. Let's look at the second part of it, 3. Let's distribute that all the way through. 3 times an x produces a 3x. And this 3 times the 2 produces a 6. Notice I have the same chunks as I did over here. And then from there, we're going to collect terms. X squared plus a 5x plus a 6. So we're looking at multiplying binomials. We can think of it visually what's happening, and in reality, or underneath the hood, what we're doing is we're double distributing everything. We're making sure there's 3 distributed across, and this x gets distributed across. Let's look at another example. So I have a 3x plus 7 times a 2x minus 4. Again, we want to make sure we distribute the 7 across both terms, and this 3x across both terms. Notice that I created 4 operations or 4 chunks that I need to do. 3x times a 2x produces a 6x squared. 3x times a negative 4 produces a negative 12x. 7 times a 2x produces a 14x. And then 7 times a negative 4 makes a negative 28. Collect like terms. That's a 6x squared plus a 2x minus a 28. And what we just did is we multiplied a binomial times a binomial, and it produces this second degree trinomial.